All right, welcome back, everybody. Welcome to Domain 8, where we're covering software development, security. And in this video in particular, we'll be talking about security in SDLC. All right, but now going back to the overall domain, this is where your organization may develop their own software. They may acquire software, which is essentially buying software. And they will be monitoring or operating and maintaining the software. So here, this is where we'll talk about how to implement security within all of these different steps or ways. All right, now going back to this video, we'll talk about SDLC a lot. Now, what is SDLC? As you see it here, I've written it 4 times, this acronym. Well, it's Software Development Lifecycle. And here are the steps that I've written out regarding the SDLC. But just remember, these steps are not perfect. You will need to know these steps for the exam. But if you have any experience with software development, your organization may use a different software development lifecycle. They may use different steps. They may call it different names. But for the exam, and trust me, you will see questions on the exam regarding the SDLC. You will see these step names and you will see these steps. All right, so this is a very important component of the exam, so make sure to take notes and to follow along. All right, so we covered what SDLC stands for. This is a software development lifecycle. This is how, or the process of developing software in a secure manner, right? So now let's get into some of the components. Now, once again, this is a life cycle, and unfortunately, because I didn't have the whole board to work with, and because I'm a terrible artist, I couldn't make this into a big circle, but just know that after transition to production, it'll go back and start this whole cycle all over again. All right, project initiation planning. Simply put, this is documentation. This is a proposal. This is where the ideas, the initial thoughts come from, and this is where you present the document to upper management for approval. Now, before you can develop any software or programs, you should always have upper management's approval. And once again, that's a reoccurring theme throughout CISSP. So once again, in the SDLC, you need proper and upper management approval. All right, now let's look at functional requirements definition. Now, you may see also in the next step, which is system design specifications. And you may be thinking, hey, David, aren't those like the same thing? Yes and no. They sound very similar, but they're a little bit different. Functional requirements definition is essentially the analysis of the specific needs that your organization has, right? And based on that analysis, this is where the design of the program or the application or the software really fits to your organizational needs. However, there's a very key component of this step that you will need to know for the exam. This is where security, actually let me spell out security. This is where security should be placed. So whenever you're thinking about the functional requirements of this software or the application, remember security. You need to implement security. Okay? All right. System design specifications. And this is where you'll notice a little bit of a differentiation between the functional requirements and the system design. And so in this step, the system design specifications, you actually look at the system or the software. And then this is where you match the designs to your organizational needs, right? So what do I mean by that? Well, your organization already has a system in place, right? It could be inputs, outputs, different peripherals. It could be different components, devices, technologies, other softwares. So you need to make sure that this new program or application that you're developing matches what you, or not matches, but can work with what you already have in your organization. Development and implementation. All right, this is the fun part. This is the meat of the software development lifecycle. Why? Because this is development. I'm a developer, so I like to develop. This is where the source code is written for your software, the source code, the original program, right? This is also where you use test cases, you conduct test cases, you look at the general use for this software. And you remember when back here in functional requirements I talked about security? Well, this is where you need to make sure that security is also in place. Why? Now, we'll get to this in later videos, but we'll talk about something called secure coding best practices. And this is where you really want to make sure that your code, when you're developing this code, you use security. You implement what you outlined in the previous steps, and you implement it here. Okay? So remember, security should be throughout this whole life cycle, but this is kind of essentially where you implement the security into the coding. All right, documentation and common program controls. So this is essentially, in this step, we're talking about, ways that we can implement controls, in particular for editing data. All right, so there's three small points that I want to talk about. So editing data, and then we also want to have controls, or we want to outline how we want to conduct logging. And I'll put logging types here. And lastly, we want to make sure that we have proper procedure in place for version storage. Right? Because as you develop software, you're going to have multiple versions. You'll find bugs, you'll find syntactical errors, logic errors, so on and so forth. You may find design flaws. So you need to make sure that you have proper version storage in regards to your source code. All right, testing and evaluation. Again, there's a few major components that I want to talk about here. Let me wipe off this board a little bit. Should have taken notes by now. And here, this is essentially where the code goes through some testing, right? And during this testing, you want to make sure that your code has data validation. That means it checks the data that it uses. Make sure that, because if your software lacks data validation, it could be susceptible to a lot of different attacks, where attackers or malicious individuals inject commands through this, especially through forms or fields. Okay. Next, we have bounds checking. And with bounds checking, you want to make sure that the field sizes, the file times, the dates, all that are structured, because without bounds checking, you are, or your software could be a victim of buffer overflows, where they exploit your fields in order to access other parts of the memory. And with that access, they could, delete data. They could see data they're not supposed to. And lastly, I'm just going to use short versions of these words, but certification versus accreditation. And we'll get to that in the next step. But for now, I want to cover what exactly certification and accreditation is. I'm not going to go in too much depth, but certification, simply put, or in the most basic form, is internal. Right? I'm not going to stop there, don't worry. Certification is where your software is analyzed by your internal team, and so they make sure that the requirements align, right, with the standards. Accreditation, you can think of it as kind of third party or external, because this is where a governing body or a standard will evaluate your software to make sure that it aligns with regulations, with industry standards, industry best practices. And so essentially, it's up to your organization's upper management to make sure that the software that they implement is accredited. And lastly, we have transition to production. And here, this is where the software in the source code goes into a live production environment. This is where you want to make sure that the software obtains security accreditation. You also want to make sure that you train new employees on the proper use of this software. And then you also want to implement this software within the overall system to ensure that it works properly and that all of these other steps that we've covered have done their job. All right? So I'm going to wipe off this board and we'll look at some methodologies that you'll need to know for the exam. All right, now let's get into some methodologies. These are development methodologies. Now, before we begin into these methodologies, I want to go into two different types, or two different major models. The first one is iterative. All right, and then we have non-iterative. Okay? So what do these mean? Iterative models means that the model, within the model, you can actually, go through different steps. It's very flexible. You are not required to go in a linear fashion. You can actually, as you go down, you can come back up. Whereas non-iterative is a very linear. It's highly structured, but it's also not flexible at all. Once you initiate this process, you need to see it through, and then on your next round, that's where you can implement your changes. All right? So, what are some different methodologies or models that you can use regarding each one? Well, to be honest, for the exam, you don't need to know every single one, but you do need to know between which of these two do those methodologies fit into. So I'm just going to list off a few for each category. So for iterative, we have agile, we have prototyping, we have rapid application development, or RAD, we have exploratory models, and for non-iterative, we have waterfall, we have spiral, we have clean room, and clean room is actually my favorite. And the reason for it being my favorite, because it goes to show you how extreme non-iterative could be, right? Clean room essentially is get your programming right the first time, which is near impossible, right? So it goes to show how structured and not flexible non-iterative is. Now, I wrote up here waterfall versus agile in two different colors, and I want to show you kind of the difference between iterative and non-iterative. So let's start off with waterfall. All right, I told you waterfall is a non-iterative model, so it's very linear. So that means you start off with, let's say, conception, then you go down to initiation, and from initiation you go down to analysis, and from analysis you go down to design, so on and so forth, right? And then you start the process all over again. Agile is an iterative process. So that means you can actually go back and forth between these different steps. So let's say you start with the conception and you go into initiation, right? Just like we did for waterfall. And then after initiation, so after you, essentially this will be the functional requirements. After that you go into system design specifications. But wait a minute. We forgot security. Well, guess what? You can actually go back up, implement security into your requirements, go back down to analysis, go to design. Hold on, wait a minute. Now that we put security in there, something's not working. It doesn't fit. Well, go back up to systems design specifications, make your changes, keep going, right? So this is what the iterative process allows you to do, is to change or to go back and make the necessary changes for your software or your program. All right, and that pretty much concludes this video. I do want to mention a few more things before we actually close out, in that I told you earlier on in the video that you will see the SDLC, you will see the components, and you will see the methodologies. One thing I did not tell you is that you know, the CISSP is very notorious for being tricky. So you want to use your best judgment. So you may see certain components of the SDLC that you're not expecting. So in those cases, remember, use your judgment. Make sure you think like a manager. Choose the best answer or the most likely answer. All right? And with that, I'll see you in the next video where we'll talk about maturity models.